Hey YouTube, welcome back to a new video. So, in the last video I had shown you how to build this primary coil and the specs and some details about it. So, and at the end of the video I tried to tune it a little bit on camera, but yeah, it worked quite good, but I was running into problems when I pushed the power higher, and that's because of the load down of the arcs. So since we know that big arcs load down the secondary coil of my, or on Tesla coils, quite a bit, the resonance frequency of the secondary coil will change, so it drops a bit. And in this case, normally we try to, how should I say, we try to set a little bit lower resonance frequency on the primary coil, so that the Tesla coil, when we power it on and the arcs begin to grow, will load down the secondary, and when the arcs getting a specified growth, both coils, the primary and the secondary, then will fall into resonance and the tuning will get right. So in this case we start with a bad tuning, but when we get higher with the input power, the arcs grow a little bit bigger, and these will pull the secondary coil into resonance with the primary coil in this case. So I hope you're getting the point. So my problem was that I have the right frequency with this primary coil, but since I have not many options available with my capacitance that I have, I only have here 100 picofarad and 800 picofarad. So in the case I want to use or still use my secondary coil like it is now on my Tesla coil, I will need a little bit more capacitance for this primary. But yeah, I have just 800 picofarad and that's way too much. So this won't work. Yeah, in that case I have to change something on the winding ratio on my primary coil. But I'm running there in the next problem, because when I want to use the 800 picofarad plus the what is it, 1 nanofarad I already have, so I will need about, I think, 22-24 turns on the primary, and that's a big problem because the primary would get smaller, and also my coupling to the secondary coil would get less, and that's a bad thing because we want to provide some, we want to get the system as efficient as we can, because an air core transformer like it is, like a Tesla coil is already really inefficient. So in the case when you build a tube Tesla coil or VTTC, you want to provide a really high coupling to get a really high efficient between the two resonators. So yeah, in this case I can't just use 22 turns because the efficient will drop a lot, and because the coupling will drop a lot. So, but there's a trick, and that is something that I want to try today and want to show you today, because I want to get rid of 4 turns. So this coil now has 34 turns, and I want to drop it to 30 turns, and I'm gonna do a little bit more spacing between the wires, so, or the windings. So in this case, when I get more spacing between the windings, the inductance and the reactance of this coil will drop. So in this case I can use way more capacitance on the coil and to reach my frequency. And the other good point is the coil will grow a little bit higher and maintain the high coupling that I need for this application. Yeah, and I would say I hope I got all the points, and I would say let's start with that. I rewind the coil and then we try it and try also some tuning of that. Just if you wonder, hey dude, why don't you using or still want to use this primary coil? It works really nice in the last few videos, because that's already my best primary coil. I used it in the last few videos and I had a really nice output with that. The reason why I don't want to use this in the future is because this coil has a really high reactive resonance resistance. Sorry for that. Because this coil has about 44 turns plus a half turn here, and is not able, or I think it's not able to push enough current into the system, because yeah, since I working with 2 tubes in parallel, these are able to push much more current than only 1 tube. And yeah, in this case I think I'm a little bit limited on the output power because I'm using this coil. So the good thing about this coil is it has a really high coupling, I think about 42%. That's really nice, and I don't have any problems with arc overs to the secondary. Yeah, and I was able to tune it really good with just these 2 capacitors. So in this case everything is good, but I think I'm limited in power transfer because of the high winding ratio of this coil. So that's the main reason why I want to experiment a little bit further with different primary coils, and yeah, just that you get the point. So that's the finished coil. That was actually this was painful. I don't recommend to do this. So I used a piece of copper wire and used it to get the space between the windings. Sometimes it fits right. So I don't got this really precise, so I measured the height of the coil and it's about 4.5 millimeters off. So it's 4.5 millimeters higher than I calculated, but I will experiment anyway with different capacitances. So I think this should be alright. Yeah, this has taken me now about half an hour to wind this coil, so still have to do the little loop to screw this on my plate for the capacitor bank. But yeah, so I will finish this and then yeah, we should be ready to try it out. So I started this coil now the first time off camera because I was a little bit nervous if everything is right, so I wanted to have my hands free. Yeah, and I find out the calculations or how I built this coil is a little bit off. So in this case, the primary reactance is way lower than I thought or than I calculated. So I fiddled a little bit around and tried different capacities, and now I'm used all my capacitors on the bank, and I'm still way too high on the frequency on the primary. But what I found out is this coil draws way more current than before. So because my ballast transformer got really quick, really warm. So yeah, now I have some options what I can do. So option number one is now to switch to the other secondary I have. This have a higher resonant frequency and also get a little bit less on the capacity on the capacitor bank. Or option two is to rewind the primary coil again and reduce the spacing between the wires. But I think I wanna change first to the other secondary because yeah, it's my interest. I just wanna try it. But yeah, I wanna show you how it is working now with all my capacitors I have. So I'm on the lowest setting again on the ballast transformer. So how you can see, the arcs are way smaller and they sound different and look way different than before. So in this case something is wrong, or in this case the tuning is wrong, so I have a little bit to work on the tuning. So I think I just tried a different secondary with a higher resonance, and then yeah, I will show you again how it is. Now I changed my secondary. Now this secondary has actually a 0.5 millimeter wire, and yeah, also on 30 centimeter wiring, and has a little bit higher resonant frequency. I also don't using this capacitor. It's 800 picofarad, so I'm at a total at about 1.1 nanofarad now. Yeah, just turn this on. I tested this on off camera too, because I was a little bit nervous about. But yeah, how you can see, this works way better. So this is a really good indicator now that I was way off with my tuning, because now I don't have any clue about where I am with the tuning. So if I mean, this will work when I'm a little bit too high on the resonance frequency on the primary, or when I'm a little bit too low on the resonant frequency. But now to see where I am with the tuning, I have the option to get rid of one of the 100 picofarad capacitors, and and I will start it again and look how this behaves. when the arcs are get smaller after I get rid of one of these capacitors, I know I'm too fast on the primary frequency, so yeah, then I have to think about it, what I will do next. I removed the capacitor. Yeah, let's start this again and see what's happening. Nothing, because I pulled the plug. Plugged it in, and now let's see what's happening. Okay, the arcs are again way smaller, sound is different, so in this case I know my resonant frequency of the primary is still too high. Because I was way too high on the resonant frequency, now I remove the second 100 picofarad capacitor, and I'm using now 2 of the 800 picofarad capacitors. This can be way too much, but yeah, anyway, let's try it. What happens? Oh. That's really beautiful. Really straight arc. Okay. I have the feeling that I should be a little bit too high with the capacity on the primary coil. But didn't look like that, and the arcs are really big too. So I think what I try next is just set the primary coil a little bit higher, because in the last video we drilled some holes in that and put some screws in that, so I'm able to move my primary a little bit higher, because my new secondary I'm now using, the winding of it sits a little bit higher, so the tubing is higher, and yeah, I think I just set the primary a little bit higher, and we will see what happens next. So now, how you can see, I set the primary a little bit higher, I think around 2.5 centimeters. So I have a little bit to be a little bit careful with this wire. It takes not too sharp turns, but yeah, let's try it anyway. Okay. Arc is again different. It's a little bit bigger also. Sounds and looks quite nice, I have to say. So just for you, that you get the point why I set the primary higher. So I want to increase the coupling, because the secondary is a little bit higher and the coupling was not ideal before. And with rising the coupling between the coils, you also rise the capacitive coupling of the coils too. So in this case, when I rise the capacitive coupling between the coils, the primary loads down the secondary a little bit more, and the secondary resonance frequency will drop a little bit with this. So in this case, this should indicate for me, or should be an indicator for me, that I'm still a little bit too fast on my primary. So I mean with too fast, the resonant frequency of my primary is still a little bit too high. So in this case, I just wanna use one of these 100 picofarad capacitors and put them in there and yeah, see what happens again. Now I put in the capacitor. So now we have in total 1.7 nanofarad. Nothing happens. It's actually... oh. Okay, we have problems at starting this thing. I mean, the arcs looking really nice. It's the type of arc that I really like. Also sounds really nice, really quiet and warm. But problems on the startup are sometimes not a good sign. Now I'm on the second lowest power rating on my ballast transformer. Oh, that's a lot of difference. Wow. Okay. Wow. I mean, this tape roll hangs about 80 centimeters over this coil. Sometimes the arcs going over that easily. That's my second lowest power setting. Okay. What we should do now? Yeah, just increasing the power a little bit more. Okay. Now the arcs are behaving really different. Interesting. Curving much more to the sides. Man. That's some serious output. Okay. I think the continuous wave output is about 75 centimeters. Nah, more like 70. Crazy. So, yeah. So now I think we have to came to an end with this video. So I tried a little bit around off camera now. So I pulled the primary coil even a little bit higher. So the output grows also a little bit bigger. But I'm running into new problems because I don't know if you can see this. on the secondary coil. I'm running here into problems because, yeah, I made this coil a while ago and it's not really proper made. So also I didn't coat it, this coil. Yeah, and these wires came loose. So that's something I have to be careful with it. So I think I wanna try to yeah, repair it before it gets worse. Yeah, at this point I think I will end this video. So it's already really long, I think. So, okay, when you like this content, leave a like there, follow or subscribe when you want to see more of this content in the future. And yeah, thanks for watching. Bye bye.